Hi, welcome back to part 8 of the motorcycle tank tutorials. I'm Alex Popov, and in this video we'll be building the cutout section of the tank shown here. And to do this we'll build a 3D curve network as we did for the side of the tank, and then construct our surfaces between those curves. Now you can see the cutout section is made up of sort of 3 sets of surfaces, a top, a lower and a blend set. So in top view we can place our first edit point curve set to degree 5. We'll use the canvas image as reference for shape, but we have to sort of offset its position a little bit to compensate for our canvas layers. Canvas image is not quite matching up. This CV we snap in line with the NCV. I'll pull this one out a bit, and that CV as well snap in line with the NCV. So the reason we snap those last 2 CVs in line with their NCVs is to imply tangency coming off the curve. You especially want that along your plane of symmetry. In this instance that's y equals 0. The reason for that is you want your reflections to match up when you come to mirror your tank. So putting the curvature comb on, you see we need to pull these CVs out using transform CV tool. We can also center the pivot and scale them, which will move them outboard. Now that we've created a bit of lead-in, we can use the align tool with G2 continuity to align like so. And then we can transform these CVs to drive the change in the aligned curve and the corresponding curvature comb. And what we want to do is create a smooth transition where the curves meet, as well as have our red or our pink when you select it. There we go, our pink curvature comb line perpendicular to y equals 0, like so. Now it's just a case of using transform CV to move the CVs just a little bit at a time and swapping between the curves, swapping between CVs. Don't try and do everything with one CV until we're happy that we've got a nice smooth curvature comb that's mirrored and still smooth. There we go. The fact that it's mirrored and still smooth shows that we will have curvature over our line of symmetry, and therefore our reflections will meet up when we mirror the surfaces. Hide the CVs and hide the locator, and we're ready to position our curves in side view. Okay, with the shoulder surfaces back to visible, I'll use those as a rough reference as to where I'm going to place these curves. The cutout section wasn't going to be seen for this build, so I had some artistic license to be a bit flexible with it. Didn't have to be particularly accurate. So I've copied and pasted the first set of curves and moved them upwards. And we want to turn our top surfaces on so that we can make sure the curves are sit above those surfaces. And that will ensure when we build our cutout, the top and cutout surfaces will intersect and we'll get a clean trim line. Now I've set the pivot point for these 2 curves, as can be seen here, and non-proportional scale them inwards a little bit so that we have some chamfer, some outward chamfer on our top section of the cutout surfaces. So with the edit point curve tool set to degree 5, I'm going to place the vertical curves using snap to control point, which is control and click, and you can see snapping to the NCVs of each of our curves. We want these curves to be as similar as possible, so what we're going to do is actually delete that last curve, and I'll duplicate either one of these 2 curves. They're exactly the same or very similar, so it doesn't matter which one we use, but we'll choose this one. Set the pivot and move into position. I forgot to copy and paste it, but it's okay, we'll pick up on that later. And now using rotate and typing in the translation 0, 0, 90, you can see it snaps along y equals 0, which is what we want. And we can stretch the corresponding curves into position and move CV and snap in line with the NCV, so we have tangency over our plane of symmetry. Okay, now with the help of curves, as we did before, using the key point curve toolbox, select line perpendicular, and draw on some helper curves that we know are coming off perpendicular to our curve set. And we can then use transform CV to slide the CVs into position. And now we know that there's a good relationship between the corresponding CVs in each of our curves. However, we don't have tangency or curvature here, so we use transform CV and in the NUV direction pull our curves until we get tangency shown by the green lines overlapping and G2 continuity shown by the red and pink lines meeting up. We want that transition there to be as smooth as possible as well, showing G3 continuity rather than G2. And the last thing we're looking for as well is that the two combs for each curve look like they're doing something similar, although they'll never quite be the same because the curves haven't been scaled proportionally, so they're a different shape essentially. So if we were to build surfaces like this, we'd be asking them to do a lot of work, so we're going to duplicate this curve, snap to the green curve using Ctrl-Alt-Click, and then rotate it, holding middle mouse button to constrain to the correct axis, and rotate it so it lines up with the helper curve. Then we can stretch it, again Ctrl-Alt-Click on the blue curve to snap to position and line it up with our helper curve. We can see this CV is a bit out of place, so slide it using transform CV tool, and the closer you zoom in, the more accurate you'll be. And just copy and paste this curve, move Ctrl-Click to snap to CV, and move it into the end position. Inspect the curve network, make sure everything lines up and is snapped to the correct places, and ensure that you have curvature over your plane of symmetry. Looks like we do. So we're now ready to move on to building the next set of construction curves. So next I'll use an edit point curve as a helper curve to define roughly where I want my boundary between my lower set of surfaces and the blend set of surfaces to be for our cutout section. And we know that we want that roughly here, so I'll just, as it's easy, I'll just snap to this surface edge, and by clicking the middle mouse button I'll drag the curve out in the X direction so I know that it's horizontal. I can now snap a curve, Control-Click to snap to CV, and holding the right mouse button to constrain to the Z direction, I'll pull that curve down, and I don't need that now, I can delete it. I'll change this curve to degree 3 in the control panel before I align it. That will make for easier, simpler shaping of our curve once we've aligned it. So we'll quickly align the curve with G2 continuity, and the parent curve we've aligned to will push the first two CVs outboard. So we just need to move this CV, hold middle mouse button and drag out until we're happy with the shape of the curve. There we go. Now, in the same way that we did for the top set of construction curves, I'm going to duplicate this, snap it into position, using Control to snap to CV or Control-Alt to snap to curve. Don't forget to rotate that end one by 90 degrees and rotate this one so it's in line with the helper curve. And copy and paste or duplicate these guys as well. Remembering to stretch into position and also pull that CV out, snap it in line with the end CV, and then we can use transform CV tool using slides to position the CVs along the helper curve, and then pull in the NUV direction to strengthen the relationship between the hulls for each of our curve. You can see each of the hulls is doing the same sort of thing. We can now put the combs on, and you'll see that we don't have G1 continuity on our lower set of curves. In the last example I showed you how to direct model your CVs to obtain G1, G2 and G3 continuity. Another and potentially easier way is just to use the align tool, sliding these CVs into position along our helper curve, and then using transform CV on the parent curve to drive our comb into a smoother transition. Now just use the stretch curve tool to snap this CV along this curve, and same again here, and we're ready to build our square surfaces. We want degree 5 by degree 5 for the first square, so it matches our construction curves, and we want position on all boundaries. For the second surface, we want G2 curvature on boundary 4, and this curve's lost position, so we need to stretch it, snap to, there we go, and now the surface will build. We only want degree 3 though, again to match up with our construction curves, so change that in the square control box. And again, degree 5 for these surfaces. I start them off all 3 boundaries, and then I change the settings so that they align along the top boundary to the top surfaces. We don't have curvature here, but don't worry, we'll fix that later. Just get the surfaces in. And no curvature there either. Okay, query edit the surface, and we need to change that to degree 3 in the U direction. There we go. So quick test is just align the surfaces and see if it works, which it does in this instance and in that instance. So there we go, problem solved. I'll apply the diagnostic shader now to just evaluate the reflections running over our surfaces. They don't need to be perfect because this bike tank build was purely for visual purposes and these surfaces simply won't be seen. So I think we'll leave it here for now, and we'll pick up on the remaining lower set of surfaces in the next video. I hope you found it useful. Thanks for watching.